First of all, I'd like to apologize to many of us that have been waiting for this video to be dropped. I am sorry, I have been partially busy doing something. That was why I wasn't able to create time to create this video. Secondly, I have a little problem with my camera. My phone camera is not actually that good. You can contact me for any further inquiries on this, and I wish you have actually watched my preparation of the iodine, the processes that I went through to prepare the iodine and to arrive at what I got in my volumetric analysis. If you have not watched that, it's important that you watch it. Yes, it's a long video, but you need to watch it so that you see the gradual things I do. It took me up to 2 hours. To be frank with you, it took me up to 2 hours. I only fast forwarded the video so that it will reduce the timing. Okay, I want you to know that there are two possible questions that I am expecting Waec to ask us from this. Remember, I want you to know that also that the work they gave us is not something you can just do by theoretical calculation. Please don't indulge yourself in theoretical calculation. If you are a teacher, please make sure you go back and watch the video. Actually, I have a little sign of the videos on this video you are watching here as I am also doing the calculation. Okay, I have two questions I want us to look into, and I will treat it one after the other. Let's start with this. A is a solution of iodine dissolved in 1 dm cube containing 6 grams of potassium iodide. B is a solution of sodium thiosulfate containing 24.8 grams per dm cube. I don't want to stress it. I would have just say something like 250 dm cubes. I don't want to stress it. If you want to learn something that looks like that, how to convert something like that, check my previous video on that. 2021 NECO, 2021 Waec. You can also change 2020 NECO and Waec. You can get how to convert that, because mostly that's the type of thing they bring. If I am Waec teacher, if I'm a Waec examiner, that is what I will bring, not just this simple work. Okay, they ask us titrate 25 centimeter cube of solution B with the solution A using start solution as the indicator. And further, they ask you to tabulate your burette readings and calculate the average volume of A used. And from your results and information, you are required to write a balanced equation for the reaction. Okay, Waec will not ask you this, but I just need you to know that it is important that you know how to write a balanced equation. But the equation will be an ionic equation, just a net ionic equation. That is what it's going to be. It's not going to be a perfect equation. Yet I'm still going to show you a perfect equation of it, yet also bring out the net equation. They say calculate concentration of B in mole per dm cube. That is question 1b. Concentration of solution A in mole per dm cube. Concentration of solution A in gram per dm cube, and state why start solution was only added towards the ending point of the reaction. Okay, it's just a simple thing we are going to treat. Therefore, the first thing I need to do is to take the practices, that is, do the titration for me. Okay, this is the opportunity for you to watch the titration once again. Okay, from the titration, we found out that, okay, from the titration, we found out something here. That I'm going to write down the values we saw in the titration. The titration, you just watch now. Going to write down the values. First of all, starting with the table. Average volume of A used in this titration is supposed to be 3, but the volume of solution A used are much. Look at 43. If you do it up to 3 times, you will consume more that you are being given in school, and therefore I only did 3 times. The first one was the rough work, the second one was the first reading, and the third work was actually the second reading. And I noticed there is a concordance value here, which is the value between these gives me 0.2. Therefore, let me just work with the first and second reading as you saw in the video. Okay, we have, so 43.20 is the end point. Okay, we can go for the questions. The equation of the reaction is, I have something to say here because while I was preparing the solution, I found it to be difficult work, and according to what the amount of potassium iodide we're supposed to use to dissolve the 25.4 gram of iodine, it should be at least 15 grams, but they gave us 6 grams. If it has been up to 15 grams, all the iodine would have dissolved. Now, what will be the percentage of it that would dissolve by 6 grams? And if you check the work I did, as you can see on the screen, the work I did actually have so many things I did here. I first of all dissolve some of the iodine inside normal water, just a distilled water, to an extent. Then the next thing I went for is I remove the water and start to add the potassium iodide gradually. That is what led me to get what I had. If I have followed the normal way other teachers have followed, my reading would have been reading towards 60 something, 50 something, 70 something. Some people might even get it to be 100 plus. I want you to get that. As you can see on the screen, trying to explain what I did in that video that led me to my value. And there is a justification for you as a teacher not to get perfectly what that you are expecting. I know your value you are expecting is to have 19 point something. No, if you use that 19 point something, you are lying, because Waec knows the people that are lying. That means that you're trying to use theoretical ideas, and the theoretical ideas you are using is faulty. Let me put something across to you. According to the normal equation, it should be like this. If you look at it by stoichiometric ideas or mass volume relationship ideas, you will notice that this value here will be, this value here should be, which if we bring them all down, we will have something in this nature. So if we are making use of 254 grams of iodine, we should also make use of 30. If we are making use of 254 grams of iodine, we should be able to make use of 332 grams. Let me bring it down. Remember, they asked us to dissolve 25.4 grams in 6 grams. That means that it is just like 1/10 of this. Look at what they asked us to do. And this 25.4 grams should be dissolving in 33.2 grams. But what they asked us to use is 6 grams. And this 6 grams is very, very low. Let's check it with calculator. 6 all over 33.2 will give us, that's approximately 0.18. If you look at it, you see that it means that this might not be able to dissolve very, very well because of the low quantity. That means that I need to grind those things using the glass rod, as you can see on the screen. Okay, that is what made this process of dissolving this thing to be difficult. I'm actually bringing this thing up for you so that you understand why it is difficult for that iodine to dissolve. If you will notice that not all the iodine that I use dissolved, I still have some remnant inside it. Okay, I am having here 25.4. That means that they should have given us 33.2 grams for all of this iodine to dissolve. But what we found out that not all of this iodine should dissolve. There will be some percentage based on who dissolve it. If you are using this should be the least of the percentage it should be. 0.18. What I have in my work is 0.4. That is what I have in my work. But this is 0.18. Okay. This 25.4 grams should actually require something like 33.2 or even 30.2, but they gave us 6 grams to use, which is very, very problematic, and it's going to cause problem to most of our teachers. And if you have followed the way I did this, as I show on the screen over here, you will understand this. Okay, we can continue with what we have here. We go on. Okay, from this work here, we can select our A. So equation of the reaction is this, and the mole ratio is, that is to say, our Na is equal to Nb equal to, we have Na, we have Nb from the equation. Let's go for the equation they asked us to do. We have to calculate the concentration of B in mole per dm cube. Mass concentration is mass given in gram all over volume in dm cube. So we will have, which gives us, there is a relationship between mass concentration and there's a relationship between molar concentration and mass concentration. So let me use that here. We have molar mass of sodium thiosulfate is 158. I'll leave my answer in 3 significant figure. Okay, from this, we have answered the question number BI. Let's look at question number BII, that is concentration of solution A in mole per dm cube. See, we have gotten concentration of B. So we have Na, we have Nb, we have Cb, we have Va, we have Vb. Vb is 25 centimeter cube as we got here. So this is the Vb, and this is our Va. Oh, I can just write it here, Va. So we have now, this is the only value that is not found here. So we look for Ca. Ca becomes, this is the only value that is not found here. Therefore, we can make use of CAVA, CBVB in this. But we are looking for Ca. So Ca becomes, dividing both sides by VANB, we will have. So we have it as, by substitution, inserting the values as we have here, we will have, with your calculator, the answer is, but if we leave this value in 3 significant figure, we will have, look at, this is the 3 significant figure, these values become nothing. We have, don't forget to state the 3 significant figure for them. It is important. Let's go for question number BIII. Now we are trying to find the gram of iodine that we are able to dissolve in that particular solution. So we have, remember that molar concentration has relationship with mass concentration and molar mass. So we repeat that again. We will have molar mass of iodine is 254. So we will have, so molar concentration becomes, making mass concentration the subject formula, we will have, if we use 3 significant figure in order for us to be consistent, we will have, please don't be confused of this and this, they are the same thing. This bar 3 is the same thing as this slash here, okay? That this stroke here and this bar 3 is the same thing. The last question was, why are we adding the start solution towards ending and not in the beginning? Okay, if you add in the first time, there is no effect of it because there is no iodine present there. And towards the ending of the reaction, there are little percentage of iodine. In the previous work we did this in 2019, it was actually the solution A that is solution B in that. Our solution A currently is the solution B of 2019. It was a little bit easier for teachers to go do away with, but this time around it's start to be a shaky work. Therefore, if you look at this value 11.5 gram we are going to use it. Therefore, the other question. The question is, why is starch solution added towards the ending point? Okay, the reason being that there were no iodine present in the beginning. Therefore, the starch will not have effect. Therefore, as we start to have iodine coming up, that is when we will start to notice. The question is, why is starch solution added towards the ending point of the titration? The reason being that in the beginning there were no iodine. As we are adding iodine solution, there start to be an increase of iodine possibility, and towards the ending there are little bit iodine solution that can be able to show the blue black coloration. Okay, let's go for second question that look like this. We are going to do just nearly the same thing of what we just did here. Therefore, work with me as we go with that. A is a solution obtained by dissolving 25.4 grams of impure sample of iodine in aqueous potassium iodide, and the solution made up to 1 dm cube. B is a solution containing 24.8 grams per dm cube of sodium thiosulfate. Put A into the burette and titrate it against 20 or 25 centimeter cube. Portion of B, use starch solution indicator. Repeat the titration to obtain concordance titer values. Tabulate your results and calculate the average volume of A used. The equation for the reaction involving the titration is, okay, iodine plus thiosulfate ion, and will give us iodide and thiosulfate. The equation for the reaction involving the titration is, as you can see on the screen. This time around I'm going to be a little bit fast because it's just nearly the same thing that I have done before that I'm going to repeat itself. The only difference here is that the questions have a third part of it that I believe should be the question they are going to ask us. From there, they say, from your result and the information provided, calculate the concentration of B in mole per dm cube, concentration of iodine in A in mole per dm cube, percentage by mass of iodine in the sample. That is the one that I believe they are going to ask. They are going to repeat what they have in 2019, but they are going to do it upside down. That is just it. And that is why I want you to please pay attention to this. It's the same thing I'm going to do. I'm going to be fast in this. It's not that I'm fast forwarding the video, but I'm going to be very, very fast because I'm just repeating what I have done before. I am not going to do the table again because the table has been done before. Therefore, let's just go straight to question number B, because I have done concentration of B in mole per dm cube in the first one. I have done the concentration of iodine in A mole per dm cube. Therefore, the question that has to do with percentage by mass of iodine in the sample is what I want to do now. You're supposed to know this value. This is the impure value, the 25.4 gram in the statement, as you can see on the screen. Okay, we go, but the molar mass is 127 times 2. So we have, then if we make the subject formula to be concentration of A in gram, this will move over here. We will have, so the value becomes approximately to 3 significant figure. So this value, we have gotten this value, which is this. Therefore, we're going to equate this all over this times this. So we have gotten this value here, which is this. So we are going to substitute it here. Then we get our answer to be, the answer becomes, leaving the answer at 3 significant figure, we will have. So by this, we can find out that the percentage of the iodine that we are able to dissolve in the work I did was actually 45% of the iodine. And if you compare it with what I said earlier about this, you will notice that it's not all the percentage we are able to dissolve. I don't know if you get that. The percentage that was able to dissolve is just 45%. That means that I actually did a strong work for me to have that. The percentage would have been 18%, as you can see here. If you multiply this thing by 1 100, it will give us 18. It would have been 18% just by normal calculation. By the strong work I did, it gave me that 45%. Now this 18%, if you have used the normal one without following the pattern I showed over there, the answer you will be having as volume of solution A used will be going towards 60, 70, 80, even 100. Therefore, if you are a teacher watching this, it's an opportunity for you to go home immediately and come to school on Monday or early Tuesday and grind your iodine and make sure that you are able to get a value that is close to mine. The first one I did, I had 54. The second one I did, I had 50. Then I changed the pattern, used the pattern that I used in this video. I had 47. Then you see what I did in the video. With God's grace, I was able to get 43. That means that if I have 150 centimeter cube given to my students, they can actually make 3 titers. But if you're having 100 and something, you might not be able to have more than 1 titer value. With 150 centimeter cube they asked us to give the student. Thank you very much for watching this video to this extent. I know I have actually wasted much of your time trying to expose you to this, and don't forget to click the notification bell, subscribe. You know that you are doing this to help me, as I am also trying to reach you and educate you, whether you are a teacher or you are a student. Thank you, and don't forget to subscribe.